So today what we're going to do is we're going to talk a little bit about similar figures and indirect measurement. We're going to talk about similar figures first, and then we'll get into indirect measurement. So let's just get into it. All right, similar figures are figures that have the same shape, but not necessarily the same size. If two figures are similar, then the corresponding angles are congruent or have the same measure. And the corresponding sides are proportional and opposite corresponding angles. Guys, right here, those are your definitions that you need to know. Now, they have little ways of, they have symbols that tell you, oh, this is similar, this is congruent, and that's right over here in this little corner right here. Let you see that if you need to see it. Okay, so this little squiggly line is read as similar to. So here, they have this. Triangle ABC is similar to triangle XYZ. So what they said is, oh, these are the same shape, okay, but not necessarily the same size. That's similar. And then they say this, the equal sign with the little squiggly line over it, is read as congruent to. All right, so they're the same, or have the same measurement. The corresponding angles are congruent, have the same measure. They're the same. Okay, so similar figures are figures that have the same shape, but not necessarily the same size. Okay, and then congruent is those are the same measure. All right, so here, triangle ABC is similar to triangle XYZ. All right, so what they're saying is that this triangle is similar to this one. Same shape, not necessarily the same size. And then they come down here and they give you this little angle. Angle A. Now this is one way to show an angle. I'm going to show you another way that they do angles here in a minute. But this is one way that they show angles. They give you that little angle sign A is congruent to angle X. So this one right here, angle A, is the same as angle X. Now notice, here's the other way that you can tell this if they just give you the figure. They give you the figure, this only has one line, this only has one line. These two are congruent when they do that. And then they come up here and they do the same thing with B. Angle B is congruent to angle Y. So B and Y. Notice they have two lines there. Two lines there, two lines there. Okay? And then they do the same thing to Z. Then they come over here and they go A and B over X and Y equals BC over X and Y equals AC over XZ. These are setting up proportions basically. AB over XY, A to B over X to Y. We can set that up as a ratio. Okay, we're going to get into that here in just a minute. Yeah. So let's take a look at what it's going to kind of look like on your homework here. All right, so in Get More Math, what they do is they say quadrilateral I, J, K, and L is similar to that little squiggly line to quadrilateral NOPQ. Which of the following statements about the quadrilateral must be true? So they come down here and they say, hey, one of these must be true. Which one is it? So what we're going to do is we're going to set this up. Now what I did is I went ahead and did this beforehand. But what you would do is you would take and you'd say, okay, there's two ways to set this up. One is to just draw it. And notice what I did is I drew one box inside of another one. And I said, okay, IJKL is similar to NOPQ. No problem. IJKL and NOPQ. All I did was draw them, and I listed them just like they list them. IJKL, IJKL, and then I listed again, OPQ, or NOPQ, NOPQ. I started here on the first one, so I started here on the second one. That's really important. If you don't do that, you're going to mess it up. All right, so this box is similar to this box. All right, same shape, not necessarily the same size. That's all I've done here. Okay, now what I can do here is because I understand that this is similar to this, then I have congruent angles in this too. This angle is the same as this angle. All right, so here's another way that you could write these angles. And they kind of do it over there on Get More Math, so I want you to see what it can look like here. All right, L, I, J. That's angle L-I-J. Okay, that's what that is. Angle L-I-J. And really what we're saying here is angle I, the center one. The center one tells you which angle it is. When they do this, they're telling you which angle. Okay? So that's one way to look at it. And then they set it up with, is congruent, okay? L-I-J is congruent to Q-N-O. Angle. And that angle sign looks really weird. Should be something like that. Whatever. L-I-J is congruent to Q-N-O. That's what it's looking like. Okay, so that's one way to look at the angles. So depending on which one they are looking at. And is this a true statement? Angle I is congruent to angle N. L-I-J is congruent to Q-N-O. Yeah, that works. Okay, but now if I change something here, let's change our other angle here. Okay, L-I-J is congruent to Q-P-O. Angle, Q-P-O. Are those two congruent? Well, L-I-J and Q-P-O, well, is angle I and angle P congruent? Well, no, they're not the same. Okay, they're not the same because it's not a representation of the same angle. L-I-J, angle I, should be congruent to angle N. So that doesn't work. Okay, so whenever we're looking at this, we need to be looking at that to see, is that a true statement? No? Okay, then we're moving on. All right, so there's that. That's how you check your angles. That's how you check your angles. Then come over here and look at this. What they're going to do is, what they say is IJ over NO is similar to, or I'm sorry, no, they say equal to, and they do, is that a Q? Yeah, QN over LI. All right, so let's take a look at this. IJ over NO. IJ over NO. That looks good, right? This line over this line. That looks good. IJ over NO. And then they do this. QN over LI. Wait. Same to same. It's got to be same to same. IJ over NO, QN over LI. All right. We're going to get back to this. I want to show you something over here. Here's what I did. I set up this quadrilateral. IJKL is similar to NOPQ. Now look at this. When I draw this line, it should be set up perfect. Each line segment should be over the other line segment. So, IJ over NO, IJ over NO, looks good. And then I come over here to, what is that, LJ? LI. LI is underneath QN. Wait, that doesn't make any sense. If this was on top, then this right here should be on top of this one. So this is not a good answer. It doesn't make any sense. Look, IJ over NO, LI over QN. These two should be switched in order for that to be a true statement. So this is not a good answer. So we're going to erase that. That doesn't make any sense. So when you set these up, you can actually set one quadrilateral over the other quadrilateral, and then you can compare it all the way down the row in order to see if it's set up correctly. Same thing, and I could switch these two, but I switched the whole of it. All of this with all of that. That's what I did right here. I switched them right there. Now, NO over IJ, PQ over KL, OP over JK. And then you also have this, NQ over IL. Okay, now remember, they can switch the numbers. Instead of saying KL, they could say LK. That's the same thing, right? LK, PQ, same line. It's still representing the same line. So watch that. Guys, this will help you to compare these things. Okay, so let's take a look at what they have over here. They have, the first one, we already said that's not true. Okay, JKL is congruent to OPQ. So is K and P congruent? K and P. Yeah, they're congruent. And take a look. K and P. They're congruent. Drawing this helps you to see that. And that's what that does. K and P. Yeah, they're congruent. That should K and P. OPQ, JKL. JKL, yeah, that should be our answer right there. But let's check these other ones. PQ over KL, PQ over JL, PQ and JL. Look here. PQ, and it should be KL. It's not JL. So that doesn't work. Oh, is it KL? Oh, I'm sorry. PQ and KL. Yeah, PQ over KL. So that's good, but the question is now, is IJ over NO good? PQ over KL, but look at what they did. They said IJ over NO. They switched those. Okay, you can't do that. All right, so that makes it not work. Okay, and then over here they say angle L and angle P. Angle L and angle P. All right, so angle L is over here. That should be congruent to angle Q. And angle P should be congruent to angle K. Watch this. They do that. And pay attention to this. This is where you're going to make your mistake. Be careful with that. Okay, you should get the angles. That one you're going to make mistakes with. All right, so that's what we're looking at here. That's how you check similar figures and congruent. All right, so now we want to take a look at indirect measurements. I want to make sure before I go there. No, okay, I want one more thing. All right, so that's just how you check to see if something's similar or congruent. But now that you understand that they're similar or congruent, you can set these things up as ratios and proportions in order to find a missing piece. All right, so here's what we can do. We know that this is similar to this. That's basically what they told us. Hey, this is similar to this. All right? And how you can do this is the same side over the same side, this side over this side. So basically you're setting it up that you have, I lost it. Yeah, same side to same side. So 5 over 30 is equal to, and because I did the small square first, or rectangle, same small rectangle first, then over here, up here, same to same, remember? Same to same. This has to be the small rectangle, if I set it up like this. So now I've got B over 24, and now I can just do how I solve a proportion, cross multiply, divide. 24 times 5 divided by 3, okay? That's all we kind of have to do here in order to be able to do this, in order to be able to solve B. Now that works with a rectangle, but it also works with triangles. Any type of similar figure, you can set these proportions up like this. So now we have this similar figure here. Watch them, because what they do is they rotate them on you to try and get you to mess things up. All right. So here, our missing side is J to K. So now I'm looking for the two angles that are congruent so I can compare them, right? They say that angle J and angle G are the same, and angle K and angle H are. So A and 4 are similar. Or, I'm sorry, similar. Okay, so what I can do is I can do A over 4 equals A over 4 equals, and then my other side, K to L. K to L, which is 14. So where I put A on top, so over here, that's where the 14 goes. Okay? Same to same. All right? Now I'm looking for this other line that is similar to this one. Corresponding angles, there and there, there and there. That has to be 7. So now my 7 goes over here. And then I'm set up in my proportion. Cross multiply, divide. Cross multiply, divide. And I'm set and I can go from there. That gives me A. Okay? That's all there is in order to solving these missing pieces on similar figures. Right? Same to same. Big triangle, little triangle over here. Little rectangle, big rectangle, big rectangle. Same to same. But make sure corresponding sides, right? Corresponding or similar sides. Get those right. All right. Let's take a look here. I want to make sure I have everything I want to do before I move on to the next one. Yeah. All right. Now let's talk about the indirect measurements. Let that focus for a second. All right. Indirect measurements allows you the properties of similar triangles to find measurements that are difficult to measure directly. With shadow reckoning, two objects and their shadows from two sides of similar triangles. I call this the shadow question. It's just indirect measurement. Think of it this way. There's a tree outside, and it's really, really tall, and you want to know how tall it is. So you measure the shadow. Well, you know how tall you are, so you stand next to it so that your shadow is also cast. So you measure your shadow, and you know how tall you are. Now you have two similar triangles that you can use in order to determine how tall the actual tree is. And you set up this proportion. Okay? The height of the tree over your height equals the length of the shadow of the tree over the length of your shadow. Now you have this proportion in order to determine how tall the tree actually is. Okay? So this is kind of useful in order to determine something that you can't tell when you know all the other information. All right? So here's what they did. Here's the statue. And this is kind of the way that it's going to look. The lead statue of the Korean War Memorial in Washington, D.C. cast a 43.5-inch shadow. At the same time, a nearby tourist cast a 32-inch shadow. If the tourist is 64 inches tall, how tall is the lead statue? This is the way that they're going to ask this question. They're going to say, we're looking for this measurement. We know these measurements. And you're going to have to set them up. And notice how they set up the triangle. Height, length of the shadow, there. So that's where your triangle comes from. Same thing here. Okay? That's the tree question. I just gave you an example. Same thing, exact same thing. And then they come over here and they go, well, all right, here's the tourist height, here's the statue's height. So they said same to same. This height over this height equals tourist length of shadow, their shadow length, over the statue's length. Again, same to same, same to same. Guys, these aren't hard. Then you do cross multiply divide and you're there. Okay? Pay attention to what they're asking. Now, suppose a bell tower casts a 27.6 foot shadow. Sorry. At the same time, a nearby tourist casts a 1.2 foot shadow. If the tourist is 6 feet tall, how tall is the tower? It's the same thing. All we got to do is set it up. All right. Bell tower casts a 27.6 foot. 27.6. At the same time, a nearby tourist casts a 1.2 foot. 1.2. Remember where you put what? Up here, bell tower. Down here, tourist. Equals. And then they say if the tourist is 6 feet tall, well, up here, I put the bell tower. So over here, we want to know how tall the bell tower is. That's the X. Down here, height of the tourist. Cross multiply, divide. This is the type of problem you're going to be looking at. Right? That's that indirect question. Setting it up. All right. Here's the other thing you're going to be looking at. But it's the same thing. It really is. What they do here, let that focus, maybe. All right. This you're definitely going to see on Get More Method. All right, give it a second. All right. Well, all they're doing is they're setting up two triangles, but they're setting them across from each other, is all it is. And hopefully this will load up here in just a second. I'll be able to deal with it. If not, we'll make our own. Basically the same thing. And then they'll have some type of scenario. But really all they'll do is they'll say that these things are similar. Okay? They may do this and this in order to show it. Okay? And yep. They'll do that. Something like that. Okay? And then they're going to set up and give you numbers across here. Okay? They may give you 6 and 4, and then 2. And they may say, find this. How much is that? Well, this and this are similar. 4 over 6 equals 2 over whatever this is, x. Okay? And then you're going to set it up and you're going to go from there. Here we go. Same thing. Little computer glitch there. All right. But if you look over here, you can see that this is the same thing as what I just set up over here. They go, okay, this angle and this angle, congruent, same. And then they say, from here to here, and here to here, they're similar. Here to here, well, we want to know how much this one is, so we got to set it up as a proportion. 10 over 16, 20 over x, to find that, cross multiply, divide. It's the same thing, all right? And you can see it over here, how they set it up. UQ, U to Q, over U to T, V to Q, V to Q, over S to T, S to T. And then they substituted in the numbers to make sure that they have it correctly, okay? 16 over 10, 16 over 10, x over 20, exactly what I said, cross multiply, divide. They show you the algebraic way in order to do this. I've given you a little bit easier way because we haven't done the algebraic way yet. Okay? Same thing. All right. Same thing here. And then they tell you, in the figure, triangle QRS is similar to triangle URT. Find the distance from the cabin to the mess hall. All right, so we want to know from the cabin to the mess hall. So we're looking for this Q to R, or the X. That's what we're looking for. Okay, all we got to do is set it up. Guys, setting this up is the hardest part of this. That's where you'll make your mistake. That's all it is. Okay? X over 60 equals x over 60 equals, so if I did x on top, this 138 has to be on top. 138 over 46, cross multiply, divide. That's all there is to this, guys. Pay attention to it, be careful with it. This one's a good question, but I've done quite a few of these, so we're going to call it right there. If you have any questions, you don't understand something, contact me, contact your teacher. Let me know if you need something.